In the 1980s, Daniel Kahneman presented his classroom with a very simple scenario. It was an economic exercise that came to be known as the Dictator Game. Player A is given a sum of money and complete power to split it however they want with Player B. Player B has no recourse, no veto, and no ability to punish Player A. Classical economic theory operates on a concept known as homo economicus. It assumes human beings are purely self-interested, payoff-maximizing agents. Under that assumption, Player A will always choose to keep 100% of the money. Over the next quarter century, economists ran this exact game 129 times, generating more than 41,000 distinct observations. The data definitively proved the textbook assumption wrong. But establishing that humans are not entirely selfish is only the starting point. The real problem is parsing those 41,000 decisions to identify the specific environmental variables that dictate when we choose to keep the money and when we choose to give it away. If you take all 616 experimental treatments run over those 25 years and calculate a grand average, dictators give away exactly 28.35% of the pie. But looking at this data as a single average is misleading. This is a chart mapping the distribution of individual give rates from 0 to 100%, and you can see the behavior is heavily skewed to the left. There is a massive spike right here at the 0% mark. Roughly 36% of participants behave exactly as classical economics predicts, keeping everything for themselves. But then we see a second prominent peak. Nearly 17% of participants choose a perfect 50-50 split. Farther down the right tail, another 5% actually give the recipient everything. The challenge in making sense of these peaks is that the 41,000 decisions come from experiments with wildly different parameters. Researchers altered the stakes, adjusted anonymity levels, and tested different demographics. Averaging these distinct studies together obscures the mechanics of altruism. To map the true architecture of human generosity, we have to mathematically deconstruct the data to isolate the hidden variables driving these behaviors. To see why simple data analysis fails here, look at this scatter plot mapping generosity against social distance. If we run a simple regression on this data, the trend line points downward, suggesting dictators give less money the closer they are to the recipient. That negative correlation is a statistical artifact. Because researchers didn't hold all other variables constant across these different studies, unobserved heterogeneity is skewing the result. Hidden factors from those specific experiments are muddying the data. To solve this, researchers use multiple meta-regression. This mathematical approach controls for dozens of overlapping variables simultaneously across the entire body of studies, filtering out the noise to find the true behavioral signals. Once the math strips away the interference, we can evaluate the actual environmental levers that reliably increase or decrease human greed. The first major lever is property rights. In the standard game, the money is a free handout. But if the dictator has to complete a task to earn the experimental money, their generosity sharply declines. The effect runs in the opposite direction as well. If the recipient is given an upfront monetary endowment before the game even starts, the dictator's willingness to share drops proportionally to the size of that endowment. Compare that to altering the recipient's status.
This side-by-side distribution chart compares the standard game against a recipient identified as a charity. The 0% selfishness mode collapses by half, and a distinct new peak emerges at the 100% mark. Altruism is not a fixed internal trait. It is a highly sensitive response mechanism calibrated to the perceived justice and legitimacy of the financial allocation. Beyond the recipient, the physical environment of the experiment itself alters economic decision-making. The vast majority of laboratory games are conducted using abstract, digitized framing. Participants are moving numbers on a screen. That framing artificially limits extreme generosity. The distribution shifts significantly when experimenters force dictators to physically handle real coins or notes during the split. This chart comparing abstract money to real money shows the impact. Touching physical cash shifts the data away from the 0% mark and significantly increases the probability that a dictator will give away the entire sum. Abstract representations of wealth facilitate keeping the entire sum. The tactile reality of physical money corresponds with a much higher probability of total generosity. Then there is the variable of social control. Experimenters wanted to test what happens when a dictator must physically stand up and be identified by the recipient they are evaluating. This distribution curve shows the shift caused by dictator identification. Being watched prevents giving nothing, but it also caps extreme generosity. The data at both extremes drop significantly, and the vast majority of participants snap directly to an exact 50-50 split. Social scrutiny enforces strict societal equity. Paradoxically, the pressure of observation actually crowds out true, unprompted benevolence in people. The meta-study also reveals a major demographic flaw. The vast majority of standard experimental economics relies on a very specific subject pool: Western university undergraduates. When we plot the student dataset against the general population on this chart, it becomes clear that students are extreme statistical outliers. The student behavioral signature is highly distinct. They dominate the 0% column, and they rarely choose an equal split. The contrast is even sharper when we compare Western laboratory data with the behavioral footprints of indigenous societies. In indigenous cultures, keeping everything is incredibly rare. Instead, the 50-50 split serves as the overwhelming default behavior. By building foundational economic models primarily on the actions of 19-year-old undergraduates, the scientific community has systematically underestimated the baseline of human generosity. By assembling the full meta-regression model and controlling for all 616 treatments simultaneously, we can weigh the relative impact of each manipulation. Specific variables restrict generosity. Having to earn the pie, upfront endowments to the recipient, and student demographics all act as negative multipliers. Conversely, older age brackets, deserving recipients, multiple recipients, and the handling of physical money serve as strong positive multipliers. Across 41,000 observations, pure self-interest registers as an extreme minority behavior. It only dominates in highly sterile, consequence-free laboratory parameters. Economists must abandon Homo economicus as the default human state. And critically, they must stop assuming that a college sophomore in a lab is an accurate proxy for global human nature.